Hello, welcome back to Sushi Live Coding. Today I will be using Spreadshirt add-on basically to kind of emulate this lesson. I was actually watching this lesson at Cadence, and this course in particular is very interesting. It teaches you some useful mathematics knowledge. Um, it's using Python and Rhino script, but then it's explained the basic really well. And then this is the one that's talking about conditional statement and the logic equations. And it's using mostly Python. It's not like nodes based, or it's not very visual. But I want to emulate something like this. Like if you are using Python and you are generating conditional statement like expressions, sometimes this is not so easy to understand, but I will try to explain it here using Blender and Spreadshirt. So let's get started. Spreadshirt, nodes, and I'll be using random vector and save this. This is a logic expression, and let's display this data. This is just a random vector, but do you often notice something about this random? This random is more like kind of randomizing it within the sphere. It's not it's not totally random. It's not like if you say, okay, generate some random points within a bounding box or something, or within a minimum or maximum value. That's gonna be more random and kind of fit a square. This one is just like fitting the radius of the sphere, right? That's also kind of like a interesting puzzle for you to try to understand why. You can randomize this further like that, of course. That's gonna give you something that's a little bit more or less random and kind of fits a square. But anyway, we don't worry about that for now. So we have this kind of like a spherical distribution of random points. If we are using some kind of expression, uh, we can actually start it to be able to slice the points within certain bounding box, and this is that sort of expression that does that. So in this case, of course, it's generating random points within um, minimum and maximum radius in x, y, z, and using these expressions with a x larger than, and then x smaller than, and all this long expression. I'm gonna try to visualize it here. So let's try and do that. So I'm gonna separate the vector. So we're gonna have the x, y, z value, right? And I want to use expressions. So let's use logic functions. And we're gonna be creating larger than and then smaller than. If I write this down on a text editor, it's gonna be like if let's say I have a minimum value and then max x is in the middle. So we have these expressions: minus 100 smaller than x. If I want to visualize this, so x is gonna be larger than minus 100, and x also, oops, x larger than minus 100 and x smaller than 100. So that's gonna be the expression. So this takes me a while to understand even now, but so let's do this. X should be larger than minus 100 and x also smaller than 100. So that should kind of, so we have like a minimum and maximum, and we can use the least mask to kind of use the data let's use an AND logic. So this is going to be a true and false, whether the points fits this conditional value. And so the output of this is going to be the mask, and the data is going to be our points. So hopefully, if I done this correctly, you should be able to see something. Okay, so it's not doing what I wanted. List level maybe needs to be level 2. Okay, now it's doing it. So if I make this value like 5,000 points, we can see clearly now this thing's starting to slice. So we have like a minimum and maximum invisible bounding box, and we can slice our sphere, which is really quite interesting if you think about it. So this is the maximum value of the x, and this is the minimum value of the x, and we can actually invert this as well. So data if true and data if false. So that's the inverted value. You can also use a boolean here. If you it should be like not. So not is the inverse of any logic value. So let's make this 2,500 again. And so we are currently only looking at the x value of the random points. We can also kind of combine this. So we can observe the y and the z, and then using all sort of the logic expression, just like this, and then we kind of have like a boolean once again. So let's see if I duplicate this 1, 2, 3. So let me hide this. So let's observe the y now, and also the z. So because this is like a visual programming, it can be slightly tricky, but this is just an simple example. So we're gonna use AND, plug this to there. So now we have control over the x min and y min. So you see, we can do slicing to this sphere, and one more for the z. So our sphere now completely disappeared. Let's make this something like that. Okay. Let's make this 8,000 points, and let's play around with the number. So there you go. That's the z. See, I can just slice into the sphere. It would actually be clearer if we are, instead of using this random vector, let me create that thing and use a vector p field, and then create 1,000 points, and that's just randomize a little bit. So I'll make it, this is like 20, that's 8,000 points. Here we can sort of doing a slicings as well. If you do like a point cloud or any kind of math study, this is kind of interesting. I think you need to understand this expression. Of course, this involves the expressions and Boolean logic, like and, or, if, not. This is all the expressions. Like if you mix 1 and 1 is equal to 1, and 1 and 0 equal to 1, or 0 equal to 1. I think 1 and 0 equal to 0. I think it's true and false. Boolean logic, all those kind of thing. That's not easy to understand, but I think this is one good example to understand Boolean logic. Okay, so yeah, that's really doing the slicings. Let's get back to our sphere. 10,000 point, and I can use randomize. So we randomize those points, and we can do the slicings. So basically, practically, this is a bounding box. We should have this as a node, and it would be cool to be able to slice objects this way. And I believe you can already do so. So if you have like a monkey head, or let's try icosphere. So I don't know if this is gonna work or not. I just plug this into that guy, and the output's gonna be so we should have our icosphere. There we go. That's our icosphere, right? That's our slicer. Minimum, maximum. Okay. And this is the face data. Oh, it's messed up. Okay. It should be like a mask vertices or something. So we have our vertices data and polygon data, and we are masking the vertices using this Boolean logic. And there we go. That's probably better. That's probably what you want. We are really just masking the vertices. So this should work with Suzanne, any kind of 3D data. So yeah, this is actually used a lot in procedural shading as well. Not always the easiest to understand, but as long you know what the function does. Oh, am I using the inverted? No. I can invert the data. Okay. It's probably more interesting. So that's subdivision, radius. You can also use the monkey head. So let's see if I can do this correctly. Suzanne, monkey head goes in there and goes in there. Suzanne, and we should be able to slice Suzanne. Where's the logic? Oh, there we go. So that's minimum, maximum. Oh, okay, we are using the inverted. Okay, so maybe I did something wrong. Yeah, but I think that's pretty interesting. So yeah, trying to explain this anyway. I think you got the points. If you want, I recommend you to study this course as well. It's titled Computing Form and Shape Python Programming with Rhino Script Library. This knowledge can easily transfer to Blender or any kind of your like a programming skills or computer graphics knowledge. But yeah, I proved my points. Boolean expressions can be visualized this way with nodes, and this is the result. All right. Hopefully you find it useful. Let me know what you think, and I'll see you next time. Thank you. Bye.